Well, hi there. So in this video, we're going to do some extra practice related to market failures, which is mostly going to focus on externalities. So let's get started. Okay, so the first section says homeowners purchase and plant trees for their personal benefit to improve the purchase of or appearance of their yards. The market is competitive. Assume the trees are also providing external benefits, and it's probably when they're being consumed, right? So it's in consumption. It's a positive in consumption, positive externality in consumption. So when we go to draw this, we're going to draw this one to the right, a graph of the market. First, we want quantity and price. It sometimes is helpful just to have that old supply and demand, that old little normal labels. We have a marginal private cost, that's our supply curve, and our marginal private benefit curve, that's our demand curve. Now, because it's a positive externality in consumption, we're going to have a second demand curve, and it's going to be greater than the marginal private one, and that's because we have an external benefit that's accruing to other people. So we have an MSB that's beyond the MPB, but that also means that the supply curve happens to equal our social cost curve. There's not an external cost here. So we have, we've done the MPC, we did the MPB, we did the MSC, we did the MSB, market quantity QM, done, and optimal quantity is QS. And again, how did I know where that was? That was where MSB equals MSC. So I know where the optimal is because that's the socials. Assume the government wants homeowners to internalize the externalities to achieve the socially optimal quantity using a per unit subsidy. On the graph, shade the area representing the government's total expenditure on the subsidy. So the amount that they would have to subsidize them by is going from here, right? From here up to here, or you could also say it's kind of this vertical point. But another way to think about this would be that it's the market quantity, right? Going from the market quantity up to the social benefit curve. And if we know that, that we want them to consume this amount, then we know that the amount of the subsidy is going to have to be enough to push this curve up by X amount, right? So this is the per unit amount of the subsidy is to the vertical distance. And I know that I'm going to want them to be at QS. And so once they're at QS, the amount that the government spends on the subsidy is that. This per unit is this, the number of units that the government subsidizes goes from 0 to QS, and then up to this new social benefit curve. And so the amount that the government spends on that subsidy is that area. And again, it's something that we didn't necessarily focus on during class, but it really is just that they want them to produce QS number of units. And so we're going to subsidize QS number, and the per unit amount of the subsidy is the amount that's that vertical distance. Assume trees are normal goods. If consumers' incomes were to increase, what would happen to the socially optimal quantity of trees? Explain. It would increase, and that's because you would have more MPB and therefore more MSB, and that would be enough of why there would be a larger socially optimal quantity of trees, right? You'd have more quantity of trees, and the reason isn't because the MSB would stay where it's at. It's actually the MPB rises, and when the MPB rises, the MSB rises also because the MSB includes it, right? MSB includes MPB. So we could add that maybe just to make that really clear. All right, let's take a look at this second one here. A graph showing us kind of two interesting phenomena. We've got an extra cost curve on here, so we know that there's a negative externality. We also have a downward sloping demand curve and a separated marginal revenue curve. And this question says, what are two market failures that exist? So the first one is kind of maybe obvious for a lot of students because we're talking about externalities. It's a negative externality in production. And I knew it was negative because it was an added cost. And I knew that it was in production because it's coming off of this supply curve. The second one is not immediately apparent to a lot of students, but this is a market failure. The fact that they have a downward sloping demand and a separated marginal revenue means that this is a monopolistic market. I can't say with certitude that it's a monopoly market because it could be monopolistically competitive, but that still is also yielding deadweight loss. And so we would say that this is a monopolistic market because you have a separated MR is less than demand. Identify the firm's profit maximizing quantity and price. Well, that's going to be where MR equals MC, and this is the MC curve, marginal private cost, right? That's just our standard MC. And so that's going to occur at Q3. and the price would be up here, P4. Identify the socially optimal quantity and price. Now, here's where this problem gets really interesting. Social cost, social benefit would be equal to each other here at P4, right? That's the same, and Q3. So this is kind of an interesting example where the firm is creating a negative externality. And so the firm is producing too many units is a way to kind of think about that. A negative externality in production means they're producing more units than what society would deem optimal. But at the very same time, it's a monopolistic market, so they're producing fewer units than what society would deem optimal. And what I love about this problem is that the folks who designed it knew that, right? That one of the market failures is causing the company to produce too much, and the other market failure is causing them to produce too little. And in fact, in the way they've designed this problem, they exactly cancel each other out. So it's such a cool little problem. I guess some people call it a trick question, but I think it's an interesting exploration of the implications of these theories. So if the government imposes a per unit tax equal to the marginal external cost, identify the following: dollar value of the tax using labels from the graph. Well, the vertical distance between these two is P4 to P1, and so that's how much it would be, P4 minus P1. That's the amount of the external cost. Profit maximizing quantity, though, after the tax would be ending up kind of pushing that MPC to be up here, and that's going to cause the new profit maximizing quantity to be Q2. Notice, right? That's going to cause this to be the new MC with the tax included. It's going to shift that curve up. And that means that the profit maximizing quantity will be lesser, Q2, and that actually caused the deadweight loss to rise. In fact, if we wanted to even shade it, we could. It would be this area right here. So we actually had no deadweight loss beforehand, but now we do. And so it causes it to increase because Q2 is less than Q socially optimal. Social optimal. I mean, that's kind of the way to say that, right? It's less than socially optimal, which is Q3, and so there would be more deadweight loss. So you can actually see that like the quantity decreases as a result of this. It's just a weird little interesting problem. All right, so we'll take a look here then at the extra practice multiple choice. Number one, which of the following is an example of a pure public good? I'm going to zoom in just a shade here and see if we can get this to focus. Pure public good, a hammer? No, because it's not. It's rivalrous, right? Pure public good would be not non-rivalrous. It would be non-rivalrous and non-excludable. So let's see if we can find one of those. Medical education to become a doctor. Well, that's certainly excludable. If you don't pay, you don't go. Hurricane warning sirens. I hear it. Can you hear it? Yes. Okay. You didn't pay. You can't hear that siren. That's not works. So hurricane warning siren is a great example of public good. Paper pulp is obviously rivalrous, and tickets to movie theater may be rivalrous, but it's certainly excludable. Public goods are underproduced in a competitive market because the free rider problem causes consumers to not know, positive externalities no, demand to be inelastic no, price ceiling binding, supply to become perfectly elastic. This is really a hard thing to think through a little bit because it's not immediately apparent. But what it actually is that we have positive externalities to increase, no, price ceiling to become binding, consumers to not reveal their true demand. That's an interesting problem, and I think that's really what we're kind of going for here. It's an interesting way to describe what the free rider problem is. What it is that consumers aren't revealing their willingness and ability to pay. Willingness and ability to pay. And that's what a free rider is doing, is they're not showing their willingness and ability to pay. So C is going to be our correct answer here. It's an interesting way to describe that. But the free rider is not willing and able to. They're willing and able to pay. They're just not showing that, right? Because we're not forcing them to pay. 3, assume that many boats have free and open access to fishing in the water of the country, which is long is true. With the availability of fish for all consumers, there is positive externality. No, that doesn't make any sense. There would have to be somebody else who's benefiting. Over time, fishing operations will voluntarily leave the market as a result of it. No, that would only happen if they're not making profit. There will be a tendency for fishing operations to overfish. Well, that would be true because there's free and open access. Reduce the stock of fish and limit the future availability of fish for succeeding generations. That is our correct answer, C. That's the tragedy of the commons. And then I do like the other two answers. The waters are a rare example of a resource that is not scarce. It's not about the water, it's about the fish. The advantage of allowing free is to limit the harm from a negative. There are too few fish. That's so goofy. 4, the socially optimal quantity of a public good is provided when the marginal social cost equals marginal social benefit. So that's true of all goods. So B, we could just say of any good, like any of them that is true. It doesn't have to be a public good. It could just be any of them. If an industry ignores the external cost it generates in the production, which the following will be true at the competitive market equilibrium. So in other words, there is a negative externality. And so we would say true at the competitive market, marginal private cost will be greater than the marginal social cost, marginal private cost equal to the social cost. Neither of these are true. So we're going to test out these price ones. And when we say this, what we're saying is you have marginal private benefit, you have marginal private cost, and we know that we have a marginal social cost that's higher. And so social benefit down here, up here, that should be what our price is, but this is our market price. So this is like our optimal price for the good, and this is our market price. So the price will be greater than the social cost. No, price will be less than the marginal social cost. So that is correct, because at this level of output, the price is less than the social cost. So B is the right answer for this one. And then number 6, which the following is not an effective way to manage the inefficiency resulting from a negative externality. Price controls, maybe, let's kind of take a look here. Lump sum taxes is going to be the right answers. So this government intervention in the form of price controls could limit the quantity produced, and that would fix the problem, right? So if we had like a price ceiling, for example, A would fix it. B, a price floor could also fix it because it would reduce the quantity supplied or quantity demanded. Per unit taxes are the traditional way. That's what we said is a Pigouvian way. Assignment of property rights can also kind of limit the problem in conjunction with private negotiations. So it's really about like C and D together. That's the Coase theorem. And then this is Pigouvian taxes, Pigouvian, right? And so the correct answer here is a lump sum tax. That's not going to affect how many units get produced. 7, which of the following best demonstrates non-rivalry in consumption? Non-rivalry means I can consume and so can you. Occupying a seat in a sold-out movie theater? Nope. Sharing rent equally among the roommates? That's not really quite it. That's just splitting the bill. Catching fish in a local pond? No, that's pretty rivalrous. Playing golf on a crowded public golf course? That's it. Not it. Listening to a radio program? That's our choice here. E, when I listen to it, so you can as well. Let's take a look at number 8. Assume the goal of the government is to increase efficiency. The cost of government intervention that increases market output from Q1 here to here, Q2 is 1.2 million. The intervention will definitely improve market efficiency if, so we have our socially optimal is here. That's our optimal. And so we have deadweight loss. That's here. And so this is our DWL. If the cost to move from Q1 to Q2 is 1.2 million, then that means that if we're going to do it, then that program, whatever this is, to go from Q1 to Q2, better be bigger than the deadweight loss, right? So if A is greater than 1.2 million, that would be worth it then to do. These other areas, B and C, are not meaningful. So we're going to rule those out. All of these other areas don't mean anything. It's just A is the deadweight loss. And then last but not least, number 9, the cost of eliminating a ton of pollution is 150 according to the benefits in the table, which is the optimal quantity. So what's our marginal benefit? Well, our marginal benefit of the first one is 300. Marginal benefit of the second one's 250. Third one's 100. See, it only went up 100. So I am not going to ameliorate the third ton. I'm going to only do 2 because it's only worth it to do it if the benefit is bigger than the cost. All right. So hopefully this helped you understanding some of the basics of market failure. I'll see you next time.